Hello everyone. Today we will discuss one more example on Euler's theorem. Here u is given as sum of two terms x raised to 4 plus y raised to 4 upon x square y square plus x raised to 6 tan inverse of x square plus y square upon x square to xy. Then we have to find second order partial derivative along with the first order partial derivative at point 1 comma here x is 1 and y is equal to. So here, as the question is to find out the partial derivative both second order and first order, here we are going to use these two Euler's theorems. So this is deduction from this first Euler's theorem. Is if u is a homogeneous function of x and y of degree n, then the Euler's theorem is x da by u by da by x plus y da by u by da by y is equal to n into u, and deduction from it is x square da by to u by da by x square 2xy da by to u by da by xy y square da by to u by da by y square is equal to n into n minus 1 into u. So together these two now we are going to apply to solve this given question. So again we will consider u as v plus w, where v is equal to the first term x raised to 4 y raised to 4 upon x square y square, and w is x raised to 6 tan inverse x square plus y square upon x square plus 2xy. So these two, so we have written in two terms w, v and u we have written in two terms v and w. So both, to say whether the u is homogeneous or not, we need to check v and w are homogeneous or not. So we know the with the previous video, now we know how to check the whether the function is homogeneous or not. So let us take here x, small x is equal to capital X t, small y is equal to capital Y into t. Substituting this in v becomes, so here x is x raised to 4, so x, capital X raised to 4, t raised to 4, after substituting x as xt, then y as yt, will get y raised to 4 t raised to 4 upon x square t square into y square t square by substituting x as xt and y as yt. So here from the numerator we can take t raised to 4 common. The remaining term is x raised to 4 plus y raised to 4, and from the denominator this t square and this t square is t raised to 4, t raised to 4 into x square y square. T square terms we have written together. So t raised to 4 will get cancelled from this numerator and denominator. It is x raised to 4 y raised to 4 upon x square into y square. So if we observe the question what is given, the same term of v we are getting. So from this same term we are getting, but in terms of capital letters. So this we can write as t raised to n into capital V, or f of xy is equal to t to the power n f of capital X capital Y. But here t term is not there, so that we will adjust here as t raised to 0, because all the t terms are already cancelled, t raised to 0. Therefore, this v is homogeneous function with degree n is equal to 0. If it is homogeneous, then we can use Euler's theorem. The Euler's theorem first order and second order both on v. Instead of u, now this Euler's theorem together we are going to apply for v, that is by Euler's theorem. Euler's theorem, x square da by to u by da by x square. So instead of u, now we are writing here v plus 2xy dabba to v by dabba x dabba y plus y square dabba to v by dabba y square is equal to n into n minus 1 into v. But here n is 0, so this entire term is 0. Similarly, first formula of Euler's theorem, x dabba v by dabba x plus y dabba v by dabba y is equal to n into v. Again n is equal to 0. This value is 0. Now adding these two, adding above two equations, will get x square dabba to v by dabba x square plus 2xy dabba to v by dabba x dabba y plus y square dabba to v by dabba y square plus x dabba v by dabba x plus y dabba v by dabba y. Right hand, this is the left hand side. Now when we add right hand side, it is 0 plus 0 is equal to 0. So this we will give as equation 1. Now similarly, like v, now we are going to check whether w is homogeneous or not. So again we have to substitute x as xt, y as yt in w. W is equal to x raised to 6 becomes capital X raised to 6 t raised to 6 tan inverse of x square t square plus y square t square upon x square t square plus 2xy means x as xt, y as yt. So here we'll write first t raised to 6, then x raised to 6 tan inverse of, from the numerator we can take t square common. So it is, remaining term is x square plus y square. From the denominator also, here we are having t square, t into t again t square. So we can take t square common from the denominator also. What we will get, x square plus 2xy is the remaining term. Okay. Now t square from the numerator and denominator we can cancel. So t raised to 6, x raised to 6 tan inverse of x square plus y square upon x square plus 2xy. So here this term we can replace by this term. We can replace it by capital W because we are getting the same term of W. Instead of small letters, here it is with the capital letter. So we'll keep t raised to 6 as it is. Here it is capital W. Small w is equal to capital W. Means again it is in the form of w is equal to t raised to n into capital W. Therefore, w is homogeneous function with degree n is equal to 6. So by using Euler's theorem here we can use Euler's theorem for w by Euler's theorem x square dabba to w by dabba x square plus 2xy dabba to w by dabba x dabba y plus y square dabba to w by dabba y square is equal to n into n minus 1 into w. But here n is equal to 6. So 6 into 6 minus 1 into w, which is 6 into 5w or 30w. Okay. Similarly, first Euler's theorem, x dabba u by dabba x plus y dabba u by dabba y is equal to n into w. So again n is equal to 6w. Now we will add these two equations. Adding these two equations, adding above two equations, what we will get? X square dabba to w upon dabba x square plus 2xy dabba to w upon dabba x dabba y plus y square dabba to w upon dabba y square. Now this is the LHS of first equation. Now we are adding LHS of second equation. X dabba u by dabba x plus y dabba u by dabba, not u, it is w, dabba w by dabba x, y dabba w by dabba y is equal to right hand side of first equation is 30w and second equation is 6w. Here 30w plus 6w is 36w. So we'll give this equation as equation 2. So now we are going to add equation 1 and 2. So equation 1 is this expression first second order derivatives along with first order derivative, but these are in terms of v. Same equations we have, so I will write below this, same equations we have for w, that is second order derivatives along with first order derivative is equal to 36w. So I'll write again this equation below this, so it will be easy for us to add. For w the equation is x square dabba to w upon dabba x square plus 2xy dabba to w upon dabba x dabba y plus y square dabba to w upon dabba y square plus x dabba w by dabba x plus y dabba w by dabba y is equal to 36w. Let me check once. It is 36w. So I am writing same equation, that equation number 2. So it will be easy now to add these two equations. So here adding 1 and 2, because equation 1 is in terms of v, equation 2 is in terms of w. So when we add these v and w, we will get the required equation in terms of u using this relation v plus w is equal to u. So when we add first term of equation 1 with first term of equation 2, we can take x square common. From this term and from this term, we can take x square common. So it is left with dabba to v by dabba x square plus dabba to w by dabba x square plus the second term, we can take 2xy common. So the remaining term is dabba to v by dabba x dabba y plus dabba to w upon dabba x dabba y. This is the second term. Now third term, y square is the common term. From third term of equation 1 and 2, we can take y square common. So it is dabba to v upon dabba y square plus dabba to w upon dabba y square plus, now next term, the fourth term of equation 1, fourth term of equation 2, we can take x common. X dabba v by dabba x plus dabba w by dabba x. Similarly, now fifth term, that is last term of equation 1 and last term of equation 2, we can take y common. Y into dabba v by dabba y plus dabba w by dabba y, which gives us, which is equal to right hand side of first equation 0, right hand side of second equation is 36w. Here by the property of differentiation, we can write this partial derivative together as dabba 2 upon dabba x square of v plus w. Linearity property of differentiation, Again, when we split this, dA bar to V by dA by x square we can write plus dA bar to W by dA by x square. Then 2xy dA bar 2 upon dA bar x dA bar y of again V plus W plus y square dA bar 2 upon dA bar y square of V plus W plus x dA bar by dA bar x of V plus W, last term plus y dA bar by dA bar y of V plus W, which is equal to 36W. Here we know that V plus W is U. So x square dA bar to U by dA bar x square plus 2xy dA bar to U by dA bar x dA bar y plus y square dA bar to U by dA bar y square plus x dA bar U by dA bar x plus y dA bar U by dA bar y is equal to 36W. But the value of W, now we are going to write. The value of W is x raised to 6 tan inverse of x square plus y square upon x square plus 2xy. So this value of W now we will substitute here. It becomes x raised to 6 tan inverse of x square plus y square upon x square plus 2xy. Okay. But this value, so this is the left hand side which is asked in the question. We supposed to find the value of this, but at 1 comma 2. So at the right hand side we are going to substitute x as 1, y as 2. So it becomes 36, x as 1, so 1 raised to 6, here x as 1, then tan inverse of x square, in place of x square 1 square, plus in place of y 2 square, again denominator 1 square plus 2 into xy, 2 into 1 into 2. So it is 36 into tan inverse of 1 square is 1, 2 square is 4, so 1 plus 4 5 divided by 1 square is 1, 2 into 2 4 is 5. So which we will get here as 36 tan inverse of 1, and we know tan inverse of 1 is pi by 4. So 36 by 4, 9 pi is the solution. This is the value of the required partial derivative at 1 comma 2. So in this way we are using here two Euler's theorem, that is first one is the Euler's theorem and second is its using its deduction. I hope everyone understood. Thank you.